Hey guys, okay, so if you watched my video about the full process of processing ICs, plastic or epoxy IC chips without incineration, then you will have noticed that one of the processes that you have to do once you have milled the ICs into a fine powder and then sieve them to make sure you haven't got any big chunks, and then you run it through the vertical magnetic separator. And the next step basically was trying to separate the plastic or the epoxy from the metal which you care about. And how we did that in that particular video was with the blue bowl. So yeah, have a look at that if you haven't seen it. But the blue bowl does have a few disadvantages. It's still difficult, so you really have to classify your material really well, which means that all of the particles in the blue bowl have the same volume, and then the blue bowl does quite a good job of separating them by density. I've been trying, one of the problems that I have with the blue bowl is that you end up, you really have to watch it, because you can't just set it off and go away for various reasons. Mainly because the velocity of the water in the bowl changes depending on the amount of stuff and that you have in the bowl. So when you initially put some material in the bowl, you have to speed up the water velocity a little bit to get it to the right energy. But then what happens is, as the bowl clears out, the friction reduces, which then causes some problems. So I've been experimenting with a way to use air rather than water to separate my epoxy from my little gold bond wires. So yeah, let's have a quick look at that. And then for those among you who are the real science geeks, what I will do is, as we run the system I've got here, I will collect all of the waste material every time. And what we should be able to see at the end after a few runs of this machine is that the density of the waste material should increase. So let me just quickly talk you through what I've got here. So I started by buying a couple of test sieves. These are Talisman test sieves, 60 mesh and 100 mesh sieves, because I figured even if I run my material through a blue bowl, classifying my material down would be a really good idea. But then I got tired very quickly of having to sieve through these fine sieves by hand. It takes a very long time, and it's quite painful to do. And so the first thing I did was I built this little setup that you can see here. I've got a piece of plywood with a hole cut in it where one of the test sieves fits snugly in. And what I've got here is, it's called an aura shaker. It basically works like a speaker, but instead of having a cone producing audio in the middle, it's got a big weight in the middle, so it just shakes or vibrates. If you don't have access to one of these, you can either talk to me and buy one, because I have a lot of them from an old job, or alternatively you just make up a shaker any way you want. The idea here is just to shake this piece of plywood so that the material works itself through the sieve without you actually having to do anything. To run the aura shaker, all I've got here is a little transformer, like a multi-tap transformer, and this one, particular one, if you can see on the side there, has taps for 0 volt, 12 volt, 15 volt and 18 volt. And the nice thing with this is I can, between 12 and 15 I can get 3 volts, between 12 and 18 I can get 6 volts. I can get 3, 6, 12, 15 and 18 volts out of the transformer. So the output of this just goes straight to the shaker via a couple of banana leads, and the reason why that works is the transformer outputs 50 Hertz, which means that the shaker will shake at 50 Hertz, where it works relatively well because that's quite a low frequency. So yeah, that's pretty simple, and then I'm just using a few car batteries to support the whole structure. Now the guts of the separation system came, like I've only really just been experimenting with this for a little bit, but the idea is that I've got this relatively large, put it on this side, relatively large plastic container, and on the side of it I've drilled a hole. If we look at the inside of it, might be better. I've drilled a hole and I've mounted just a PC fan on one side, and the PC fan gets run from a variable bench power supply. So I can change the voltage that goes to the PC fan and thereby change the speed that the fan turns at, and basically change the energy of the air that the fan is pushing. And so yeah, so you guys can pretty much see where this machine is going to go now. So I'm going to start off by grabbing a lunchbox size container, and the lunchbox size container, just get rid of the lid there. The lunchbox size container, we're just going to slide in there. And so if I turned on the shaker and filled this sieve up with some material, so the material I'm going to run has already been classified and all of it will go through a 100 mesh sieve. If you want to know what the size of that is, just Google, just have a look at Wikipedia. It does describe what the actual micron size for a 100 mesh sieve is, but it's much finer than a kitchen sieve basically. So without the fan, everything would sieve through and it would settle slowly into the lunchbox down there. With the fan blowing, and initially at a very low speed, but then what we'll do is every time we run the same material over, we'll increase the speed a little bit. Initially you're going to blow away the lightest stuff and it's going to settle on the far side here, and only the heaviest stuff will fall into the lunchbox. And every time that we rerun the same material, we will be increasing the voltage to the fan by a few volts. I'll mention what numbers I'm using as we go. And the idea with that, of course, is that eventually we should end up with only the heaviest stuff, in the lunchbox. Okay, I'll quickly set this up. So what I've got here is some, I'm not sure what let me tell you what the volume is if I can read it on there. It's about 200 milliliters of ICs that have been milled fine and then had all the magnetics removed, and then it's already been through all of my sieves to make sure that this stuff will pass through a 100 mesh sieve. So most of my bond wires hopefully will actually be in this stuff. And the objective here, of course, is just to remove the bulk of it so that we can go do an acid treatment without the struggle of having to always deal with this amount of plastic stuff. Okay, so you'll see a couple of small improvements here. So we've got the lunchbox inside in its location. This is the high-sided lunchbox that we use first. Got just a sheet of plastic on top here to keep any dust that gets blown in that direction contained, and any dust that does make it out. I've just got a little bench extractor fan with filters sitting here, so try and keep the dust in the workshop to a minimum if there is any escape. It isn't actually as bad for dust as you might imagine. Surprisingly, vibrating this thing at about 50 Hertz with that really fine powder, and it doesn't actually seem to create a lot of dust. So let me quickly power this up, and then I will show you what it's doing. So we'll start off by feeding. So we'll feed the Aura shaker with 12 volts, and I'm not sure if it's going to be visible to you guys, but I can hear a little bit of a rattle there from one of the battery terminals that it is working. And if you look right where I'm going to zoom now, just on the inside there, you should be able to see a little bit of fine dust make its way through the sieve. I think one of the keys of making this thing work is that you basically have to have your powder quite fine like that as you're trying to separate it, because you want to avoid clumps, because obviously clumps aren't going to separate your plastic from your gold very well. So if we just zoom out a little bit from that one, I'll show you what's happening at the top. So nothing much exciting there. You can hardly see that there's anything happening. The vibration, so there's no dust really created by the vibrating of the sieve there. I haven't put all of my material in. I found it's best not to overload the system too much. And if we look through there, you will see already quite a bit of material inside the lunchbox, and also quite a bit of material that is blown past the lunchbox. So I think that's probably a good place to end for now. Once I've run all of the material through once and I've done the first clean out, we will have a look and see how the volume of these that we're interested in has been reduced, and then we'll just carry on with this experiment. Okay, so I've come to the end of the first run here. Probably took about an hour to run that 200 milliliters or so of material through the 100 mesh sieve again. I'll just show you what everything looks like here, because I obviously have to get in there now to separate the stuff we want from the stuff we don't want. So we've got the filter here, not too dirty. There's a little bit of stuff collected up on top here, as you can see there. Anything that makes it past and all the way up and collects there is not going to be gold bearing, so we'll just dump that off the side there. And as you can see in here, we've got a lot of very fine material collected in here, and then the stuff that's not quite so fine collected on that side. So what I'll do now is I'll just collect both of these up into little containers so we can compare how much we eliminated with the first pass. Okay, so I've just done the first stage clean out, and as you will see there, we got roughly 70 or 80 milliliters or so of waste, and we captured about it's going to be about 120 milliliters or so of material. This is what we're going to run again now. So the first time we run this system, I had the fan running at 4 volts. This time I'm going to up the fan voltage to 6 volts, which is going to be roughly a 50% increase in fan speed, and therefore roughly a 50% increase in air energy. And yeah, and then what I'll do is I'll run that now, 6 volts, then I'll clean it out again, and we'll look how much material we separate on the second run. And then I'll basically keep on doing that until we have a very small amount of material left in our big container. Okay, be back soon. Okay guys, so we have done 5 runs of the separation system here, and I'll just show you the result of the 5 runs. I'm trying not to shake this container, because if you look at it like this, I expect a lot of the heavy stuff to have fallen in this area and the lighter stuff to have been blown over into that area. You'll also see this is now the lower container, because I couldn't increase the fan speed more than 12 volts, but I could use a lower container which allows heavier stuff to blow over the side. If you look down there, you'll also see that I've got labeled samples of the 4 runs, and then the 5th run still has to be cleaned out from the bin. But what we'll do with all of those is we'll compare their densities, just to see if the different fan speeds and the different height of container made a difference in terms of the average density of the stuff that was removed. Looking at the results here, I'm not immediately seeing a lot of gold. I wasn't expecting much gold to start off with, but I thought what we might do is just leave it as is and just take a look under the microscope, because there are definitely some sparkly bits in there. So we'll just see if we can find some bond wires in here. Hopefully we won't find too many along that side, because that would mean that the bond wires are getting blown away, and I may have lost a few over the top. But this is the first experiment, so let's go to the microscope and the scales and stuff and see how we go. Okay guys, so what we're looking at here is the final container. So this is the one that we were hoping was going to contain most of the gold, and what I'm looking at here is the side of the container where I expect most of the gold to have fallen, and hopefully this shows up as well on the video as it does for me. But clearly as I move the container under the microscope, yeah, it worked very nice. As you can see, we've got a lot of gold sitting on this side of the container. I'm moving to the edge of the container now, so not going to be quite as much gold here. Still the odd little bit and bump. What I'm going to try and do now, without mucking up the microscope too much, is I'll turn the container around so that we'll look at the side of the container where the reject stuff was blown to, and I might have to just do a little bit of a refocus. Yeah, so you guys can see there much more of the black stuff, but also quite a lot of gold bond wire. Yeah, so quite a lot there, which means that the airflow at 12 volts with the low-sided container was probably enough that I may have blown some gold over the edge of the container. Luckily, obviously, I've kept everything that came out of the big container, so, and they're all nicely separated. So what we can actually do is we can go through the containers one by one now and just see. So this is what we're looking at, obviously, is the container that I was hoping would capture most of the gold and very little of the epoxy. So when I come back, we'll have a look at the next container, which should contain hopefully more epoxy and hopefully very little gold, but we'll have to see. Okay, I'll be back now. Okay guys, so what we're looking at here is the second container. So this is the stuff that could be blown over the edges of the low-sided catch container at 12 volts. So this was the final stuff that I removed from the big bin. And as you can see, if you look, try and line things up a bit, but certainly appears to be a few bond wires in there. If I go to the main bulk of it looks like that, so you'll see there's the odd bond wire, but obviously nowhere near as many as we had in the there's another one lying right on top there, nowhere near as many as we had compared to the amount of black stuff. So I'd say 12 volts with the low-sided container on my particular setup. So not much there. If I towards the edge, I could see a few more. So not much there. There's a few. You can clearly see them there. It's actually very hard to see this stuff with the naked eye. Without the microscope, you couldn't even tell those are there. So yeah, obviously this was a bit overcooked. So I think in the future what I might do is just stick to the high-sided container and possibly run the same stuff through a few more times. So let's quickly have a look at the third level. So the stuff that I removed just before this, and then hopefully in that which was done with the high-sided container at 12 volts, we won't find any bond wires. Okay, be back soon. Okay, so what we're looking at here is the third container. So this is the container where where we're looking at the rejected material with 12 volt fan on the high-sided catch container and very much reduced amount of gold. But if you look, for instance, right there in the middle of your screen, you'll see one bond wire. Now, if you compare this to the first one we looked at, obviously is a big difference. But this goes to show that even 12 volt with a high-sided container might be over the top. I might have to just run the fan very slowly and run the material. See, there's a couple more bond wires right there. I'll see if I can improve the focus just a little bit. Yeah, I think that's about as good as we're going to get it. But you can clearly see definitely a few. If I just scroll through it, you can see there are definitely a few bond wires caught up in this one as well. There's another one there, a few more. So yeah, so it looks like I might have to rerun all this material at a much lower fan speed and then try that again and see if we can basically eliminate this problem where I'm losing bond wires. So this is very much the same problem we have with any other system as well. Any form of washing you do has a tendency to lose some of the stuff you want together with some of the stuff you don't want. But Yeah, that's looking okay. Let's just as a matter of interest, what I'll do now is I'll just work out the relative densities of our 4 catch containers as well as our end container of the stuff we're going to keep for now, and we'll just see how that works out. Okay, I'll be back soon. Okay guys, so I've just measured all the volumes of each individual container here, and I've got the weight of each individual, well, the contents of each container, and it did work out pretty much, did do exactly what I thought it would do. So we start out with container 1, where the average density is about 0.84 grams per milliliter. Number 2, we've got 0.91, so the average density is going up a little bit, so 0.91 grams per milliliter. By number 3, we have got just over 1 gram per milliliter. Then number 4 is just over 1.1, and number 5, which is this is 5 milliliters, and this is the result of starting with 200 milliliters of stuff. So, and this is the first 2 containers that I showed you on the microscope as well. So there's quite a lot of black stuff in here that can probably be reduced with a low fan speed and just running the same stuff a few times. But the density of this one is well over 1.2. So this one is 1.24 grams per milliliter. So not sure why we're not focusing there. There we go. The system works as advertised. So obviously I've checked that this one contains a lot of bond wires. This one contains a very small number of gold bond wires. I haven't checked this one yet, which will be the next thing. I'll just check by myself to see. I'm not expecting any. So this was high-sided container and 9 volts on the fan. So I'd be very surprised if that one has managed to blow any bond wires over the edge, but I'll just check it anyway, and then I basically know that I can set the fan for 9 volts and just run all the material through nice and slow, maybe run the resulting material through 2 or 3 times, and essentially get nice clean concentrate, which is now going to be fairly easy to process, versus the 200 grams of material, or 200 milliliters of material that I started with, which is, so all of this basically adds up to about 190, which corresponds roughly to what I measured at the start, so we didn't lose too much in terms of dust in the workshop either. Yeah, so that's today's little project. I think the machine has some potential. Please feel free to leave some comments if you think there's something I can improve, or you like it or dislike it. Let me know. Thanks. See you guys later.